it's not hard to imagine in the near distant future that AI is so democratized that really everyone has the ability to kind of train their own models. With every single piece of information that we consume, anything we create, anything we touch, it's all going to be kind of fed into this like fine-tuned model that is really, kind of an extension of us.
Welcome to the Edge Podcast. I'm DeFi Dad here with Nomadic from 4RC. Today's show spotlights Inference Labs. In this episode, we discuss how this team is solving for AI verification, one of the biggest challenges to realizing the fullest vision for decentralized AI, including their ongoing work with Bittensor and EigenLayer. But before we do, just a quick word from our sponsors who make the Edge Podcast possible. Power up your portfolio by borrowing, lending, and multiplying your favorite assets, made safe and easy by the industry-leading automation tools at SUMMER.FI. SUMMER.FI offers a curated DeFi experience to access the highest quality protocols and strategies. Discover new earn strategies for your portfolio in a user-friendly app designed to filter based on the tokens you hold, the networks you transact on, the protocols you trust, and the highest available yields. Learn more today at SUMMER.FI, the best place to borrow and earn in DeFi. Tired of hopping between tabs, searching for new tokens before the hype catches on? Try MATCHA.XYZ, the DEX aggregator from 0x. MATCHA connects hundreds of DEXs so you can trade millions of tokens and find fresh new drops. MATCHA works out the best route to save you money on every trade. Swaps are free and MATCHA has everything you need to trade on-chain. Gasless swaps, limit orders, and cross-chain, all in one place. Search Trade Done at MATCHA.XYZ. Introducing Flat Money, the first decentralized, delta-neutral flat coin built on Base with sustainable yield that's completely untethered from legacy finance. Because DeFi needs an uncensorable based unit of currency. You can mint unit with RETH, which is held in the protocol's shared liquidity pool, where it's borrowed by leveraged traders. As a leveraged trader, you can deposit your margin collateral and go long on RETH. If you're trading in the perpetual futures market, you'll pay unit holders to open leverage positions. If you're holding unit, you'll earn yield from liquidations, borrow rate, and trading fees. Preserve your purchasing power and offset your exposure to crypto market volatility. Learn more at flat.money. Catch the tide of the mainnet launch of Puffer Finance. Whether you're an Ethereum staker or an aspiring node operator, Puffer delivers the decentralization revolution with its cutting-edge technology. Start with just 2 ETH to unlock the potential of native liquid restaking and maximize your earnings. Join the movement now and anchor your stake at puffer.fi. All right, let's introduce Ron Chan, the co-founder of Inference Labs. Ron, welcome to the Edge Podcast. How are you doing?
Oh, fantastic. Thanks for having me, guys. Really appreciate it.
Yeah, so good to see you again. Today's conversation is going to center around why do we need decentralized AI? Inference Labs helps to overcome one of the many obstacles to get us to a decentralized AI future. And so we're going to break that down today and talk through all of that here with Ron. So Ron, why don't we just get started with more about who you are, what you've worked on previously, and then would love to get into the genesis of Inference Labs.
Yeah, absolutely. So Ron Chan, I'm one of the co-founders of Inference Labs, business partners with Colin Gagich. We've actually been working together for quite some time, even on a previous exit. So I've known Colin for over 8 years. Myself, I've been a serial entrepreneur for about 2 decades now. I've had 3 exits from the companies that I've launched. In fact, one of those exits was acquired by a public company in 2021. I've worked in industries ranging from building data centers to national defense projects. And that national defense project, one of the large ones is NORAD. That is a North American Aerospace Defense Program up in North Bay, Canada. It's between Canada and the U.S. And also, like the exit that I mentioned there was in civil aviation. I launched that startup about 10 years ago. It initially started off in digital transformation. We had all that kind of like iPads being kind of launched, the mobility devices, And essentially, it went from digital transformation, and that product line ended up evolving into embedded systems and then machine learning in 2018. That deployment ended up scaling out to about 60 different airports around the world. Notable ones would be Chicago O'Hare, which is the largest in passenger volume in all of North America. FedEx's main distribution hub for the United States. It took 18 months to pour the concrete on that project. It is now the largest de-icing facility in the world. And international ones like London Heathrow. We deployed a machine learning system there, and it basically provided visual guidance for aircraft during winter conditions. And we essentially had a service level agreement with these airports that we really need to position aircraft within 2 meters of a specific point 99% of the time. We exceeded those metrics. The AI that was deployed there was a non-recurrent neural network of computer vision based on image classification, object detection, and segmentation. The same model that we trained in 2018 is still used in production as of today. 2018 AI was very different. The compute was very different, much slower. And as well as that, there's no data sets for aircraft. So we need to get airlines to volunteer crew and aircraft to help train these models. So it was interesting because one of the actual use cases there, and I mentioned in 2018, they're still kind of using the model. And it's interesting because we had to go through a pretty extensive process to actually get this AI computer vision system approved. There'd be site acceptance testing, and they didn't necessarily actually want the state-of-the-art model. They wanted one that was actually proven and tested that actually achieved those kind of SLA goals. In terms of crypto, we kind of entered that space in 2017. What's interesting about that is in 2017, it wasn't just kind of protocols back then. There actually was another narrative, if people kind of remember. And essentially, it was IoT. IoT and Web3 as an intersection was a pretty amazing use case. And what was interesting was with the civil aviation work, we actually were using cellular communication as a backhaul. And we needed something, because it was mission critical, we needed something as a backup. And that's when we started investigating LoRaWAN networks. And when we kind of tapped into that, that's when we kind of bumped into the whole crypto IoT rabbit hole, whether it's Helium network or any of the other IoT networks. So that's kind of how we got here today.
Appreciate that, Ron. I think maybe we just start at a high level, and I would love your take on how you see centralized AI right now, and maybe frame up some of the problems you're seeing emerge on that front. I think that'll better set us up to talk about decentralized AI.
Yeah, for sure. A lot of people kind of say, centralized versus decentralized. I don't really look at it as two partisan concepts. We come from an engineering background. We're more pragmatic. I kind of look at it as technologies have some sort of value proposition. There's no one size fits all. In a lot of certain cases, centralized AI is actually more performant. It's a lot better. If you kind of take training, for instance, we have these billion-dollar data centers, and they're optimizing and they're using optical switching. And all of these systems are running at the nanosecond range. Conversely, if you talk about decentralized AI and training, and you have a node that quite possibly could be, in North America and another one in, say, Australia, you're talking hundreds of milliseconds. And that's just orders of magnitude difference in terms of time. And, essentially, we do start kind of bumping up into physics there, in terms of communication. It can't really kind of transmit information faster than the speed of light. So there is situations where centralized is going to be a lot more performant. Not to say, there isn't an area to solve with decentralized training. We're actively kind of working in an ecosystem there. But I'm just providing kind of an example where the barrier to entry is much lower for centralized AI. The real problem I see isn't really a technological one with centralized AI. Currently, I think it's more that centralized and proprietary AI poses kind of like a huge risk. We previously have been like a technology partner in the past, working on another project where we amassed like 2 terabytes of social media data. And through managing that massive data set, what I've seen is like Fortune 500 companies, even political parties, use that information, to kind of analyze our behavior, help influence, our purchasing decisions and whatnot. And really, I just see that we're kind of at the cusp where AI is just going to be so deeply embedded in our lives. It's not hard to imagine in the near distant future that AI is so democratized that really everyone has the ability to kind of train their own models. With every single piece of information that we consume, anything we create, anything we touch, it's all going to be kind of fed into this like fine-tuned model that is really, kind of an extension of us. And what's kind of scary is actually just recently in the news with Microsoft, they're kind of like aiming for that goal. And it's actually, they're implementing it even at an operating system level. So it's like watching your behaviors on how you kind of work is pretty scary in terms of, how powerful something like that could be. And really, when you kind of like look at that, we see AI being leveraged where we can kind of like use it and actually, improve our productivity as well as help us achieve our goals as well as our dreams. I actually personally want to embrace all of that, except for one exception. It needs to be completely self-sovereign. So I really couldn't imagine like a world where I kind of lose control of that model or an external party uses it against me. Essentially, like there's even questions out there. It's like, could like a fine-tuned AI model be used against someone in the court of law? And fundamentally, this is kind of like our thesis on why decentralized AI must exist and be an option to a centralized one. Control just can't be left to for someone else, based on trust or, intermediaries with that environment.
I want to get to AI verification here in just a moment, because this is the meat and potatoes of what Inference Labs works on. But if we were to look at decentralized AI as like, let's call it like an engine, are there any other parts to that engine, Ron, that you would call out? This is before we really focus on your expertise. Like, I'm just thinking about like the major components of the decentralized AI engine. These could be adjacent projects or protocols, innovations that you think are important that will work alongside what you all do at Inference Labs.
Yeah, no, that's a great question, DeFi Dad. I think overall there are a lot of problems to decentralized AI. It isn't kind of like a magic bullet. I had mentioned from a technological perspective, it actually does have some trade-offs as well. So areas that I think that need to be like essentially solved, just because it's labeled decentralized, I think we've seen in Web3 in environments where it's labeled as crypto and decentralized, but really under the hood it's still quite centralized. And when I kind of say that, I guess what I can kind of like provide as an example is that if you kind of look at AI as a perspective, these complex AI models, they're actually quite large. They really cannot fit on the blockchain. They're gigabytes in size for anything complex or useful. In terms of the blockchain, like it's too slow for an AI model to actually run on chain. So really, right now, the only option for decentralized AI is actually kind of running those AI models off chain. And really, when you kind of run those off chain, you kind of just reintroduce those trust assumptions. You're basically kind of heading back towards that centralization. And honestly, it's a non-starter for us, right? If you're kind of working in Web3, the whole reason why is because you want to kind of remove those centralized points of failure. So really, I kind of look at, running off-chain AI compute or inference, I kind of see it as like a spectrum of trust. On one end, you have like a black box. Essentially, you need to trust the operator that they faithfully executed the model. You don't even know if there's an AI model that exists. And you have no control over whether or not that model changes. So that's a really big barrier to interoperability, and especially in a decentralized environment, you see a lot of that. And I actually kind of mentioned this in my example with aviation. Like in that particular use case, they didn't necessarily want the state-of-the-art model. They actually had a site acceptance test, and they actually kind of approved it based on how it operated. Even if we collected more information and kind of tweaked the model, it could actually regress in its performance. So number of parameters in a model doesn't always equal better results. Another example in terms of use case would be having a conversation with my accountant. And for instance, if my accountant's firm was leveraging an AI model based on tax law for 2023 to actually kind of fulfill tax filings, they don't necessarily need that state-of-the-art model for tax law that's related to, to 2024. So yeah, essentially, there's a lot of situations where AI models in operation, live in production, needs to go through some sort of human vetting process or performance review. And lastly, in the frame of, say, like Web3, smart contracts don't have an intuition. They don't know if, this model all of a sudden has changed or it's not as performant. And essentially, we can't have models just change. Like we actually see that in L1s or other smart contracts, protocols doing upgrades where we see dApps break and testnets break because the underlying technology all of a sudden, changes. And we can't have that for an AI model, especially when we're kind of talking about this agentic economy that we're heading towards. We just basically can't have that trust. We essentially need that cryptographic certainty. On the other end of that spectrum that I was talking about for trust, we have open source models. And what's interesting there is that it's actually that whole industry has been doing like amazing work, and it's essentially those open source models are going in leaps and bounds. We're actually seeing where open source models can actually beat some of the proprietary ones. I've been looking at some scoring on the testing, and these open source models are actually very close to ChatGPT's newly released 4.0 model. And it's interesting what's being done there. And I think we're almost at an inflection point that the open source models are actually going to overtake the performance of the proprietary ones. In terms of like another advancement on these open source models, hasn't necessarily just been on the performance of the model. We're actually seeing a lot of the open source models being actually distilled down. Smaller models that are more performant in certain areas. And the reason for that is because we see where there's an actual use case for open source model running at the edge and essentially, on consumer hardware. A lot of advancements with, say, Apple Silicon, or even on your cell phone. We're actually seeing these models being distilled down and becoming much, much smaller. And what's interesting here is when they are smaller and they're kind of running on your own devices or your smartphone, in essence, it's actually kind of like a trusted environment. So when you're talking about open source models, the real question is, do you really need decentralized AI altogether? Because it essentially runs on, a local device. And another area for open source on the trust spectrum, that I'm talking about, is essentially that when you have an open source model, you might not necessarily want all of the weights and biases, all of that proprietary information or non-proprietary information revealed. And one particular use case would be, for example, you wouldn't actually be able to, say, have an open source security AI agent. That wouldn't necessarily work because malicious actors basically could kind of analyze that open source AI model, take a look at its detection methods, and really counter against it when it's operating in public. So what we don't really have in this decentralized AI on spectrum of trust is something kind of in the middle. And essentially, we basically want something that allows for some privacy-preserving properties for the AI model operators, but also provide consumers of the predictions that come out of those AI models some cryptographic certainty that the inference was performed on a specific decentralized model. I guess the best example I could kind of give you here is, we really wouldn't access our online banking or our health records or insurance without, say, HTTPS or TLS or SSL. We secure websites to basically ensure that we're accessing the correct site, not one that looks like the site we're trying to access. We've seen it all, the phishing scams and everything like that. We're looking to kind of deliver the same thing, which is HTTPS, but for AI models. And really, our central thesis is that these technologies and protocols need to be kind of solved first before we kind of expand into this agentic kind of Web3 based economy. So how do we do this? Essentially, Inference Labs is addressing this need by abstracting the way of AI model operators deploying these models in a decentralized environment. So essentially what we do is we take this AI model and convert it into a base mathematical representation. In our case, we're using ONNX, which is a kind of an open standard. And when we actually do that, what we can do is apply an interesting technology, which is zero-knowledge cryptography. And when we do that, something interesting kind of happens out of that. What is created essentially is a ZK circuit. And that particular circuit, you can kind of think of it as a fingerprint. That fingerprint basically is tied to that specific AI model. So in other words, when you actually interact with an AI model and get a prediction out of it, you can actually ask for a cryptographic proof to go along with it, which will provide you with the certainty that the prediction came from a specific model.
Before we get back to the show, just a quick thanks to our sponsor at Mantle Network, the layer 2 that pioneered the 5th largest LST with 1.6 billion TVL called MATCH. Since July 1st, Mantle is running a 100-day airdrop campaign called Metamorphosis to distribute a new governance token for the Mantle liquid staking protocol called Cook. The community can earn points for Cook called Powder by holding METH in Metamorphosis and simultaneously enjoying other yield and reward opportunities in the Mantle ecosystem. Users can also earn Powder by staking MNT in the Mantle Rewards Station. For more details, go to the Mantle blog at mantle.xyz/blog and follow the 0xmantle handle on Twitter for more updates. Ron, with everything you just shared, I'm wondering if you could give a few more examples of what does today look like without Inference Labs, without AI verification, versus what tomorrow looks like the future you're building towards with this solution in place?
Yeah, absolutely. I think that the state of the industry right now is a lot of progress is being made in the open source side of things from a decentralized standpoint, and it is great. But we all are kind of talking about what is that next step? And really, when we kind of interact with AI right now, for the most part, everybody's kind of asking, when are you going to circuitize an LLM so that I can interact with that? And my question is, that particular LLM, like ChatGPT, do you really need to circuitize it? When you're kind of interacting with, say, ChatGPT now, you're just essentially kind of taking that wall of text and using it somewhere. I think in terms of the actual development of things, and as these models start improving, what you're going to have is, instead of just taking that information is now going to turn into some sort of actions. And a lot of the narrative around kind of crypto AI right now is focused on an agentic kind of environment. And it isn't just exclusive to Web3. I've never seen, in terms of all the technology cycles, more developer interest than in developing AI agents, whether it's Web 2 or Web 3. That's certainly the direction that things are going. And if we're going to have a model essentially take action, essentially right now, without any type of verification, I kind of mentioned it's a black box. And, you can kind of look at, other cycles in crypto and Web 3. That black box just doesn't work. Let's say somebody jokingly says, hey, I have 100x trading bot, just send me some funds. And, I used to work for these investment banks, and here's my pedigree, but I'm not doxed, and here's my pseudonym. Essentially that is a non-starter. That doesn't work. We know what ends up happening there. We have no idea if there's an AI model to begin with. So essentially, I think in the future, when this kind of all plays out, verification is just going to be something that nobody really talks about. It just is there, very much like HTTPS, and it's just going to be ingrained in the native protocol.
Ron, I know you've launched a Bittensor subnet. I admittedly definitely have not grasped everything about Bittensor, so maybe you could kind of give us like a quick primer on what is Bittensor, and then I have some follow-up questions just about what you're doing with that arrangement. But yeah, what is Bittensor? Can you kind of give us a quick overview?
Yeah, absolutely. It's I kind of mentioned earlier in the talk that typically centralized AI, like these monolithic kind of proprietary systems, they already kind of started off. They had a head start. They control massive troves of data. And that data is like trained essentially in isolation. It's not benefiting from any like collective intelligence. There is a particular narrative that they will probably be following, and it lacks kind of any diversity. What's interesting about Bittensor is that really it's the most active and largest AI chain, I believe, right now in terms of artificial intelligence activity. And essentially what it is the largest decentralized machine learning network of peer-to-peer intelligence. So basically, they're kind of incentivizing machine learning, gathering data, collecting it, fine-tuning models, but in an open environment. It's open access. Anyone can kind of participate. And essentially, it's doing some amazing things in terms of the greater good there. Overall, I've seen like the actual crypto economic incentive model behind the scenes. It's quite powerful, and I think there are some amazing projects and subnets that are being launched right now.
So how are you as Inference Labs leveraging Bittensor then?
Yeah, another great question. So Bittensor essentially operates on a UMA consensus method, and it really allows subnet operators to kind of define their own like incentive mechanisms. And in our case, with our subnet number 2, Omron, we actually ended up kind of creating one of the largest ZKML proving clusters. Currently right now, I approximate it probably has about 2,000 cores, 15 terabytes of RAM, and we launched the subnet in April. And one of the kind of reasons why is because a lot of the questions we had in terms of AI verification was that who is going to pay for this computation? Essentially, we had, HTTPS. I do remember a day when acquiring an SSL certificate cost $20,000. So as important verification is, who are the kind of operators? And really, we kind of look at essentially decentralized AI as this kind of like value chain, supply chain of some sort. And when we're kind of talking about decentralized AI here in this case, there are going to be different like slices. And one of the areas that we wanted to kind of vet out and build like an actual working cluster was on the infrastructure side of things, the compute, the ability to actually come up with these zero knowledge proofs.
Say Bittensor didn't exist, like was there a way to do this without it? Or I guess what properties has it enabled you?
Yeah, it's pretty fascinating. So essentially, it's twofold. What we've actually been able to see, and we believe in kind of like open participation, open source work. That's the reason why I actually believe these open source models are going to be more performant than proprietary ones. Everyone thinks that open AI almost has unlimited resources. Like Microsoft's thrown billions and billions of dollars at them. They have no issues raising capital. But one of the barriers to that is that you just cannot have the same level of developer interest in a proprietary system as you would with an open source one. There's just so many more people working on solving some of these problems. And by having this kind of open participation network in Bittensor, we've actually kind of changed the incentive properties of our subnet so that we actually incentivize people to not fine-tune and create bigger and better models. We're actually incentivizing them to actually take models and distill them down so that they are actually circuitizable and verifiable. What we actually discovered during all of this was actually kind of like this feedback loop, because it was a competitive environment. In essence, we actually kind of created a competitive like Kubernetes cluster. And by doing that, when we initially launched our model on there, we actually saw like the initial proving times on launch was about 20 seconds. In just last week, we actually broke the 4-second barrier. So that enabled us to actually see that there are people interested in working in the space, believe in verification, and actually kind of enhancing the whole ZKML stack. We've actually seen, besides people working on vertically scaling the hardware with like compute cores and memory, they actually were looking at optimizing how can they actually optimize their infrastructure to come up with faster proving times, or leveraging GPUs in zero knowledge proofs. So the other aspect as well is kind of part of our go-to-market strategy. I had mentioned Bittensor really is, in essence, kind of the most active AI chain that exists. What we're building here isn't just necessarily, in terms of verification, just for our own subnet use. We actually see that proof of inference as a consensus method, it makes complete sense to many other subnets, because those other subnets that are fine-tuning those models want to actually be able to provide value externally outside of the Bittensor ecosystem. They might be tapping into other chains or even into Web 2.
Teller is a decentralized protocol that enables anyone to borrow or lend using any Ethereum asset. You can think of a Teller loan as a DeFi cash advance, one where you can use any of your favorite ERC20 tokens as collateral to get an instant USDC loan. Discover the power of a DeFi cash advance today at teller.org.
At Moonbeam, we're building a world where the wonders of decentralized technology are accessible to everyone. We're advancing Web3 integration through product enhancements, funding for innovation, and investment in our partner ecosystem. Our product roadmap includes ZK initiatives, tokenomics updates, and 8x throughput. Our $10 million innovation fund invests in startups that deliver cutting-edge solutions for RWAs and Web3 gaming, and our partner ecosystem continues to grow through grants and incentives. Moonbeams is delivering frictionless user and builder experiences to create the future of the internet on-chain. Join us by participating in the Moonrise campaign today.
So I know open source communities, like your point about a proprietary versus open source, like open source communities can just ship and help, many hands make light work type environment. But curious if people that are maybe helping you with your subnet or contributing, are they incentivized purely via Tau, the Bittensor token, or is there some ultimate like incentivization mechanism that you as Inference Labs are also kicking in? Because I would assume it's both most likely, but maybe you could actually answer that for me.
Yeah, that's fantastic, and we kind of looked at it through the exact same lens. There are criticisms of any kind of crypto economic incentive model, because once you kind of have some value there, essentially people are trying to figure out how to game it, extract that value, and they might not actually have that value exchanged. They might just get liquidated or off-ramped. Yes, absolutely. I see that in the Bittensor network. I think it's absolutely important that it isn't this Ouroboros of rewards, essentially having just like a validator and miners and subnet operators kind of churning through this and off-ramping Tau. It's absolutely important that there are these kind of external interoperable economies that tap into Bittensor. And you're hitting on a great point. That's the whole reason why we want to have proof of inference. How do we actually get output from the Bittensor subnet into, say, Web3, There are other projects that are working on kind of tapping into marketplaces and allowing people to kind of access it with fiat and, essentially have subnets perform work based on kind of bounties. So yes, that's a great question. And I think subnets do need to address that.
Ron, there is another product, I believe you pronounce it Sertn, but it's spelled Sertn. It's being built as an EigenLayer AVS. What can you tell us about that, and why did you choose EigenLayer to secure it?
Yeah. So really that's kind of stitching it all together. And what I kind of mentioned here is the importance of tapping into other ecosystems, because that kind of AI value chain, it doesn't stop with just one particular segment. So essentially, Sertn is going to be a universal inference verification layer. We actually recently just launched it on public testnet, and essentially it's going to operate as an ABS on EigenLayer. I think what EigenLayer has done is pretty incredible. We kind of see like an opportunity here, right? I've already kind of identified it. There is essentially a lot of AI operators, people that are investing thousands of hours or millions of dollars to actually create these useful AI models. They need a way to actually kind of deploy that in a decentralized environment. And maybe what I can kind of describe is kind of like a Web 2 example as an analogy. We're all familiar with a product in Web 2 called Stripe. Stripe itself is, the payment system. And really, if you're shopping online, you're really not seeking out a website that's using Stripe. Stripe just happens to be there on your checkout process. The reason why they've been so successful is because they've abstracted away the difficulties of accepting payments online and also removing that kind of liability of having credit card information or PII. They've just made it easy for these operators to essentially insert 3 lines of code and boom, all of a sudden they can accept credit card payments. They can also then continue to focus on building out their business and growing that. We're looking at doing the exact same thing, but for Web3 and AI operators. Essentially, what we want to do is kind of abstract away that difficulty, because really these data scientists don't all come from a development background. And even if they are developers that are familiar with Web3 is an even smaller room. And then when you kind of add Web3 in cryptography, you're talking possibly somebody that has like a master's in computer science and maybe a PhD in cryptography. We're looking at trying to abstract all of that away and providing it as like a very useful kind of code chain for these different decentralized AI operators. I think what we can kind of see is essentially in the future, the ability to kind of abstract away these challenges of kind of running an AI model and providing value. I think the data scientists themselves will come up with these great models that can provide value. They don't want to actually kind of run the infrastructure or even maybe program a front end. Take Midjourney as an example. That's a generative image AI platform, and they did a great job of abstracting away their user interface. Midjourney arguably is probably one of the best generative AI products out there, and they don't have an interface. They've completely offloaded that to Discord, and I can see like in a future where Midjourney might not even want to run the infrastructure. They might not want to run like the data center that's behind it that's generating these images. They might just want to kind of focus on fine-tuning their model and building out their business. That might be outsourced to, say, a DePIN provider or something like that. We've seen this also in like Web 2 and previous technology cycles. So in essence, there's an open source project on the infrastructure side called Elasticsearch. AWS does a great job, and essentially they offer a open source package, but all wrapped up neatly in an open search platform on AWS. That way people or developers don't need to kind of work on updating their servers or anything like that. They can just use the product. So essentially with Sertn, we're looking at doing the exact same thing here. And by actually launching a network, something interesting also happens. We end up kind of building this network effect. Not every prediction requires verification. When you're kind of interacting with ChatGPT, you don't actually take every single prediction. Sometimes you prompt it a few times. What Sertn allows is the ability, because of that network effect, to essentially kind of prompt and interact with these AI models, see on chain that they previously have had some verification in the past, have some level of confidence to continue to work with it. But ultimately, if you're going to take action and take a prediction that you're going to base a decision on, that's when you could actually ask for that cryptographic proof or incur that computational kind of overhead to come up with that proof. And by doing so, by using this kind of AVS, essentially what we do is have a challenge window so that there is a request for proof, and that AI operator needs to come up with that proof, or at least a valid one, and within a specific period of time. And essentially that network effect can kind of work across multiple chains. So I think what EigenLayer offers with that shared security really helps us. It also allows us to kind of bootstrap relatively quickly. There's no necessity for another L1 unless we absolutely actually have to have it.
I think this is such a good addition to our AI crypto playlist. I know we are always feeling so lucky to be in conversations with folks like you, Ron. So just thanks for coming on, because you can't have these conversations just anywhere. It's such a niche, small world within the niche world of crypto still, and the niche world of AI that is going to have an impact on every single person on the planet, I think, ultimately. But I want to remind our listeners that they can learn more about Inference Labs by going to inferencelabs.com. They should follow Inference_Labs on Twitter for updates from Ron and his team. They should also follow Ron's Twitter account at pseudo_Ron. All of that is in our show notes, so you can easily reference it. And then, as I was just saying, Ron, thank you so much for coming on. This was just awesome to be able to deep dive with you into AI verification and Inference Labs. Could you close us out, though, with just maybe like one more milestone that we should look forward to over the next 6 to 12 months? Like, what's the thing you're most excited for in the roadmap ahead for Inference Labs?
Before I do that, thanks so much for having me on here. That's an incredible milestone. What you guys are doing, all of your work, it's much needed in this space. There's a lot of static, right, in terms of people having conversations, what they're kind of shilling and whatnot. And it's hard to kind of cut through a lot of the noise. So thanks again for all of the work that you guys do over there. I guess, joking around about the shilling aspect, the next few months are going to be super exciting for us. All of our code base is being released publicly. Essentially what we're kind of looking forward to is stitching it all together. We have, tapped into 2 different ecosystems. We want to be able to kind of connect everything up and start actually having that kind of inference traffic. Everybody has the ability to kind of interact, and it's open participation. We're going to be kicking off, incentives for people to kind of continue running miners, validators, even point system, further incentivize engagement across all of our different platforms. So yeah, thank you so much for having me.
Thanks everyone for tuning in. If you're a talented founder or developer, please consider reaching out to our team at fourthrevolution.capital. And for future episodes of the Edge podcast, please check out our link tree at edge_pod.